Good afternoon. Am I audible? Thank you. So first, we briefly recapitulate what we have discussed in last lecture. So in last lecture, we have discussed about the addition and subtraction. You have solved a number of problems on addition and subtraction. How actually we can add and subtract by using 2's complement technique. We have seen what is the difference between sign and magnitude, 1's complement and 2's complement. So mainly, we have used 2's complement for the addition and subtraction. We discussed this diagram. So these are the two registers are there to hold two numbers. Suppose if you want to do addition of two numbers or subtraction of two numbers, obviously two registers required. So two registers are there to hold the value of two number. And suppose if you know if the number is a negative number, what we have to do? We have to take a 2's complement of that number. And that time we have to take this 2's complement value if the number is negative, right? So that's why this is input is there for the switch. So if the negative value is there, so switch will choose this complementary value at the time of subtraction. And if it is addition, the switch chooses value directly from register B. So this switch choose the register B value directly if the number is positive number, because no need to complement. If the number is negative number, we have to take 2's complement of that number. So accordingly, the switch is there to choose input as per the operation, addition or subtraction. And finally, you know, even if you are doing a subtraction, still the adder is required, because always we add even though you are doing a subtraction. How? By the complementing, right? First we take a 2's complement, right, of one negative number, and finally we will add. And accordingly, you get the result. But what about the multiplication? So in the last lecture, we discussed about the multiplication. So here we have seen mainly this flow chart, which is very simple. So briefly recapitulate and then we'll start today's topic. So here we have seen mainly there is these different variables are there. At initially, we initialize A is equal to 0. C is a carry bit. M is multiplicand. Q is multiplier, and the count, right? If the 4 bits are there, so the count would be the 4. If the 5 bits are there, so count would be the 5. And how many bits will be there? It just depends upon the number. If the number is, for example, in between 7, so obviously the bits will be 3. If the number is around near about less than 15, the total number of bits will be 4. So how many round are there? 4. So this count will depends upon how many bits are there. So indirectly, it depends upon what is the value of a multiplicand and multiplier. So at the first step, actually, what we have to do, we have to check what is the value of Q0, the last bit. If the last bit of Q0 is 1, then what we will do? We will add A plus M. And then we perform shifting operation in C, A, and Q. If Q0 is not a 1, it is 0, so that time we will not add A plus M. Directly we perform a shift operation. And we rotate this operation multiple times until and unless this count became 0. So always this count subtracted by 1 bit. So if there are 4 bits are there, so n value would be 4, and always will be subtracted by 1. So finally it goes to 0 and then end. So when actually the execution end, you will get the product A and Q. So yesterday we have seen how we get the multiplication in between uh, this multiplier and multiplier. And when you calculate this combined value, in last lecture we have seen 1, 2, 4, 8, 16, 32, 64, 128 to 56 in this way. When you will add uh, 128 plus 1 plus 2 plus 4 plus 8. When you will add all this value, you will get the multiplication number, the multiplication count. Right. So within 2 minutes, again, I recapitulate this example that we have seen in last lecture. So here at initially, we initialize A is 0, C carry bit is 0, this multiplier and multiplier Q and M. So 1101 and 1011. So what is the first step according to the flow chart? The first step is first we have to check this Q0 bit. So this Q0 bit is 1. So if it is 1, then A plus M, right? So here the Q0 bit is 1, that's why A plus M. So A is what? 0, 0 and M is 1, 0, 1, 1. So after addition, obviously you will get 1, 0, 1, 1. So A plus M perform here, this addition. Next step is shifting. So yesterday we have seen how this bit shift to here, this bit shift to here, in this way, this side. But the shifting is in between C, A and Q, not in M. So 1 bit shifted at this location. And if this Q0 bit is 0, then only the shifting will perform. So C Q0 is equal to 1. If the Q0 is 0, then directly we shift. So here the Q0 bit is 0, that's why the shifting operation is only performed. So finally, you will get the answer. So here, when you will calculate 1 plus 2 plus 4 plus 8 plus 128, you will get the multiplication of this two number Q and M. So this example we have seen. So today we have a tutorial. So in tutorial, we will solve number of problems on this example as well as the Booth's algorithm that we are going to discuss today. So listen carefully. Again, this is another example. If you could understand now, you can solve this problem in tutorial. Okay. The example is very simple. First example I have taken very simple. So before that, we'll discuss what is the need of Booth's algorithm, right? What is the need of Booth's algorithm actually? The need is, here we have seen the number is unsigned number. The number is unsigned number. But here, you want to perform a multiplication in between -5 and -3. So, unsigned number means the number is not positive number or not negative number. It is unsigned. The sign is not there, neither positive nor negative. So that time, whatever technique we have discussed earlier, that is okay. No, not an issue. But suppose if the multiplicand or multiplier is a minus value or both are minus, then our previous technique does not work. But if you want to use the previous technique only, so what is the solution? How you can use? The first, what you have to do, you have to convert both the number into the positive number. First, you have to convert both the number into the positive number. Then multiply a number as our previous technique, like a previous technique. And then if the signs were different, like at one side it is a minus and another sign it is a plus, that time we have to negate the answer. So this is one way by which actually, even though the number is signed number, If there are signs are there, either positive or negative, but still we can solve a problem by using this technique. These are the steps that we have to follow. But again, this is not an efficient approach to solve a problem whose signs are different. So what is the solution? So solution is a Booth algorithm. Solution is Booth algorithm. So if you want to multiply to sign number, the good approach is Booth algorithm compared to the previous technique that we have discussed for unsigned number. But by using that unsigned number also, you are getting a result. But if you apply same technique as it is for the signed number, you may not get a result. That's why there is another technique that is a Booth algorithm. Or what you have to do, you have to first convert your negative number into the positive number, and then you can multiply. And if both the signs are different, obviously you have to negate the number. So in the solution here, what we have discussed, there are a number of steps, extra steps that you have to perform if you are using previous technique for negative number. So if you want to minimize number of steps, the solution is Booth's algorithm. So in Booth's algorithm, in less steps, you will get the result. So what is the difference? How actually Booth's algorithm works? Actually, you can easily understand by this flowchart. Okay. So I will wait here. You first draw this flowchart, which is required by. Okay. Already I told you, you should have a notebook and pen.